Okay, here's an A-shaped bulb, 600 lumens, 10 watts, cost me around $15. All those numbers are very non-competitive. By the fall of 2013, $15 should easily purchase an 800 lumen bulb at 10 watts. So not very good looking. The only thing in the back I noticed that might save this bulb is it has a CRI of greater than 87. So let's tear it down, see what CRI means, and see if it justifies the what appears to be on the surface very non-competitive price. Okay, what do we got going on here? A bunch of color swatches, paint samples of course, and there's no real rhyme or reason to the colors I chose off the paint shop. So red, some green, some blue, a gray and a black, and sort of an off-white, and then a plum. 3 bulbs. There's an incandescent bulb, and by definition of CRI it's 100. There's the Cree bulb, which has a CRI of 80, and here we have the Ikea bulb with a CRI of 87. And if I understand CRI correctly, the colors will render differently. So what I'll do now is I'll switch my camera into a fixed white balance mode, so it won't try to autocorrect. Turn each bulb on individually and see if there's any sort of visual difference. Okay, so here's the first photograph. Now, unlike the video there, I was showing 3 different lamps. Actually, I centered the bulb in the same position and then illuminated the samples evenly. Now, it might be a little hard to see in the YouTube video. I'm uploading this at 720p. If you pause it, you might be able to see a difference. The red and the greens show sort of the greatest difference. Now, I must admit this effect is fairly subtle, and I think, quite frankly, if you want to change the quality of light, you might just do better to purchase a higher Kelvin bulb than the CRI. But yes, there is some truth to it. The Ikea bulb does create light which does look different than the Cree bulb, the standard 80 CRI bulb, not the TW. Another photograph here, I took a picture of a flower. Again, it has a nice collection of greens and reds. That seems to be where the effect is. Again, if you pause this video and look at these 3 different flowers taken with the 3 different bulbs, there is a subtle difference. So in that regard, yes, this is one thing that the Ikea bulb is producing. Now, since this bulb was released, of course, there are now color-enhancing bulbs like the GE Reveal and Cree TW, which are yet again even far superior than this bulb, and quite frankly about the same price. So this one advantage Ikea did have in the fall certainly falls away quite quickly. Okay, polar plot data. The bulb here, of course, since it's known as a polar graph, and if you measure the light coming out of the bulb at various angles and plot the number and import those numbers into a spreadsheet like Excel, you can get a graph which indicates how the bulb's light comes out. And what this one's telling me is that the bulb, of course, has light coming out here, and of course in the front, and of course much less in the back, and that's of course typical of an A-shaped bulb. Now this pattern's much better than their 400 lumen bulb I tore down earlier. That was a very poor emulation of an A-shaped bulb. This is better, although I suspect when I tear it down it'll be a downward firing bulb because the lots of energy coming out of the top front here. Which is good for some light fixtures and not so good for others. I have another YouTube video which goes through that. So this is an acceptable pattern though for an A-shaped bulb. Okay, let's talk about a parameter called flicker. Solar cell here, of course, converts light to electricity, and we look at the output on an oscilloscope. You'll often see a waveform. 120 Hertz is pretty common in LED bulbs. The height of this waveform basically gets translated into a perceptible flicker. Some people are actually amazingly sensitive to it, and if you're using lighting for like movie uses like this, you can actually see it on the camera. This bulb, peak to peak, is sort of a relative measure, but if you hold the amount of lumens falling on the solar cell relatively constant, here's a little table. I'll map up some of the bulbs I looked at other than this one. You can see like Philips, for example, has been consistently excellent in this factor. The Ikea is definitely coming in at the lower end of the range though. Is the bulb dimmable? This is just fine bulb. It seems to work well even with this dimmer, which certainly isn't rated for any LED use. Okay, let's talk about power consumption. This is a watt-hour meter measuring the amount of watts the bulb's consuming. You can see it's reading 11. The packaging says 10, so I think the packaging here is rather optimistic to what the bulb I have. It seems to be drawing 10% more energy. Okay, so far beyond the CRI index, it's a fairly unremarkable bulb. In fact, actually the price-performance ratio is quite low. In 2013, Ikea certainly doesn't seem to be offering class-competitive bulbs. Let's tear this thing apart, see actually who made the bulb, and see what we can find inside. Okay, certainly an unremarkable bulb from performance specs, but take the top off, and the neat thing about this market, of course, is that the everything inside the bulbs tend to be very different still. Here's yet again another construction I haven't run into, a bi-level set of planar LEDs set up here, and a set down here, and it looks like some hand-wired solder to connect the two emitters together. How interesting. Okay, so further into the disassembly, the emitter array here has been unscrewed, and you can see that the power supply is held in this plastic sleeve with the Edison A base, and the additional emitter array here looks like it's just a ring that's been attached to this casting. The thing that holds the power supply, here it is over here, we'll look at this in detail in a minute, it just slides in here, and of course there's a fair air gap between the plastic and the heat sink, so that really tells me that the thermal management for the poor power supplies can be quite tough. I mean, the heat basically has to conduct out of the base because of the very poor heat transfer you're going to get from a plastic sleeve to a piece of metal, because you can see there's no sort of heat transfer compound. Inside here, there of course was the power supply, and the standard potting compound. This provides a good thermal transfer for the electronics, and obviously some other electrical isolation, I should imagine. Let's zoom into the power supply and see what we can see there. Okay, this is the AC-DC converter, AC input on the left, and of course the DC output on the right. Going from left to right, we see a fairly standard topology. A fusible resistor here, providing an input protection, two coils plus a capacitor forming an EMI filter. One of them's fallen off. Very standard. On the back here we'll probably find a full wave rectifier. Here it is. So AC input, then high voltage DC output from the full wave rectifier, and off to a controller circuit, which is in the center of this one here. This is a Marvell, a 88EM8183 it appears. This is the controller which really determines your flicker performance, your dimmability performance. For example, the Philips bulb I tore down recently has a much superior topology from Cirrus Logic, which produces almost no flicker, a real testament to engineering. This Marvell unit, much more representative of the market, having a fair bit of flicker. This is the MOSFET, of course, the controller. They keep the MOSFET separate because the die area is fairly significant. Switching transformer here. Unusually it doesn't PC mount, actually had a couple flying leads. It probably had to be hand soldered, so not a good sign from a reproducibility of manufacturing. You don't really want too many people in your process. Some other very classic things in the back here. You can see some slots cut out. These are for achieving better isolation. Circuit board material, of course, is not conductive, but if you want even greater insulation, you can cut out and use air. Other than that, the only thing you really notice actually, there's absolutely no identifying marks as to who's made this board, whether it has any traceability. I guess they're not using UL on this product. They use this other Intertech for certification, so maybe they have different regulations, but you can't really find out much about the board other than that, who IKEA is actually procuring from. The filter capacitors out here, these are rated to, I think they're 105 degrees centigrade, ashy. They seem to be seeing those a fair bit in these teardowns here. These are two components which, of course, are responsible for reducing flicker. You can see it's surface nut components in the back here. You can see where there was parts which were not populated in this SKU. The little red dot, that's a glue. They glue the SMT parts down first, then they stuff the through holes, and then they waste solder the assembly, so fairly regular process. Alright, continuing the theme of this bulb of being just incredibly unremarkable, this is a really standard topology for a power supply. Okay, let's talk about safety marking. You can see something here, ETL. This is similar to UL and CSA. The strange thing about this bulb, unfortunately, is that although there's a mark on the packaging, there's no ETL mark on the actual product itself that I can find. And when I search the database, which is much less sophisticated, the UL databases are far superior, I can't find any marking on the bulb, which is very strange because I thought that was actually a requirement. If I look at the other 400 lumen bulb from Ikea, you can see they actually do have this ETL mark on the actual product. So honestly, I don't know what the certification status of this bulb is, so that certainly would cause me concern and would prevent me from using this in my house. Okay, well that was the review of the 600 lumen bulb from Ikea that I purchased in the fall of 2013. There's a story on the web about Ikea switching all their lighting into LEDs. Certainly they're going to have to do much better than this bulb here if they want to be class competitive. The price, the number of lumens you got out of it, the watts consumed were all well below what the industry leading bulbs have at the moment. The only feature of this bulb actually that some other bulbs don't touch is the higher CRI, and even that, quite frankly, you can get the Cree TW now, for example, at the same price, get more lumens and get even a higher CRI. So certainly Ikea will have to step up its game in 2014 if it wants to be offering competitive products.